Welcome back to Nomenclature. Please have a periodic table as you take your notes. Elements bond with each other to form compounds in order to become more stable. When bonds are formed, elements obtain an octet, that is 8 electrons in their highest energy level, and this gives them a stable electron configuration. In ionic bonding, electrons are gained and lost in order to attain the octet. In covalent bonding, electrons are shared to attain the octet. In both ionic and covalent bonding, the resulting compound is neutral. That is, it has no charge or an overall charge of 0. In ionic compounds, nonmetals, which have a high electronegativity, gain electrons from metals which lose electrons due to their much lower electronegativity. This results in ion formation, and the ions strongly attract each other in whole number ratios. Binary ionic compounds are made up of 2 elements only. There can be more than one of each element in the compound though, and if you look at barium iodide, there is 1 barium atom that is bound to 2 iodine atoms. Let's look at the steps for writing formulas for monovalent binary ionic compounds. In step 1, we determine the charge or oxidation number on each ion. For example, will be magnesium fluoride. So magnesium has a charge of +2 and fluoride has a charge of -1. In step 2, we write the cation with the charge first and then the anion with the charge second. So in our example, magnesium fluoride, we will write Mg with its charge of +2 and F for the fluoride ion, which has a charge of -1. In step 3, we manipulate the quantities of cation and anion as subscripts to balance the charges. Remember, the total charge on the compound should equal 0. In our example, we have magnesium with a charge of +2, so the total charge on the cation side is +2. The fluoride ion has a charge of -1. So right now, the total charge on the anion side is -1. So they don't balance to give us that total charge of 0 in the compound. So what I need to do is multiply my -1 by 2 to balance out the +2 on the magnesium side. Now, +2 and -2 balance each other out. Therefore, for each 1 magnesium ion, I need 2 fluoride ions. When we write formulas, the 1 is understood, so my final formula is Mg at 2. So a few more examples. Calcium oxide. Calcium is Ca for the cation, and it has a charge of +2. Oxide comes from the oxygen, so I have O with a charge of -2. Step 2 is to balance out the charges to get a neutral compound with an overall charge of 0. So since I have a +2 and a -2, they balance each other out. So for every 1 calcium, I need 1 oxide ion. And here's my formula. Again, the 1s are understood, so I don't write Ca1O1, but I write CaO as my final formula. The next one is lithium nitride. Lithium is over here. So lithium has a charge of +1. Nitride comes from nitrogen. So I have N with a charge of -3 for the anion. I have to balance out the charges. I have a total of +1 on the cation side, and I have a total of -3 on the anion side. So in order to balance those two, I will have to multiply this one by 3 to get a total of +3. Now the +3 and the -3 balance each other out together. Therefore, I need 3 lithiums for every one nitride ion. Finally, we have barium phosphide. Barium is here, so it has a charge of +2. And phosphide is here with a charge of -3 again. So on the cation side, I have a total charge of +2 right now. And on the anion side, I have a charge of -3. To balance the two out and make it equal, I have to multiply the barium side by 3 to get a total of +6. And I have to multiply the phosphide side by 2 to get a total of -6. Now the charges balance out. I have a +6 on the cation and a -6 on the anion. So write my formula as Va 3 and P2. Now let's name monovalent binary ionic compounds. If I have the formula NaCl, I name Na sodium. I name Cl as an ion, chloride. Remember your "ide" ending. And we have sodium chloride. If I have the formula MgCl2, I name the first ion, which is magnesium. Then I name the second ion, which is chloride. Again, don't forget your "ide" for the anion. And I'm done. Notice that it doesn't matter how many of each ion there is. In this case, there were 2 chloride ions, and I still named it magnesium chloride. Let's do a couple more to practice. So LiCl, Li is lithium, Cl is chloride, and I'm done. Ca is calcium, F is fluoride, and it doesn't matter that there are 2, I still just write fluoride. A is radium. Again, it doesn't matter that there are 3, I just write radium. And the anion is nitride. And I'm done. Now let's take a look at compounds with polyatomic ions. Polyatomic ions can be anions or negative ions, and sometimes they can be cations. And an example would be ammonium, NH4+, and another example, mercury 1. These are pretty much the only 2 positive polyatomic ions that we are going to deal with in this class. Now be careful. Polyatomic ions often end in "ite", whereas monoatomic ions end in "ide". Let's see how we write formulas for ionic compounds with polyatomic ions. So the first rule is to write the cation and anion formulas with their charges. In our first example, we have calcium nitrate. So we write the cation formula. Calcium is Ca with a charge of +2. And nitrate is NO3 with a charge of -1. Now, just like before, we have to balance our charges in order to get a neutral compound with a charge of 0. So on the calcium side, we have a total charge of +2. And since nitrate has a charge of -1, we have a total charge of -1. Now these don't balance out, so I have to multiply the nitrate side by 2 to get a total charge of -2 to balance my +2. So what that means is for every 1 calcium, I need 2 nitrates to make up my compound. So my formula will be Ca, 1 calcium with 2 nitrates. Now, because polyatomic ions are a group of elements bound together, in order to show that I have 2 nitrates, I need to put my whole polyatomic nitrate in a parentheses with the 2 to show that we have 2 nitrates. Now again, 1s are assumed, so I'm going to have Ca parentheses NO3 with a 2. Now please note, you do not ever alter the formula of the polyatomic. You also do not distribute the numbers in the parentheses. What that means is if I have CaNO3 parentheses 2, I cannot make that become CaN2O6. That is completely wrong. Our second example is ammonium carbonate. This is a compound involving 2 polyatomic ions, but the rules stay the same. So ammonium has a charge of +1, and carbonate has a charge of -2. These don't balance out. In order to balance, I'm going to have to multiply the ammonium charge by 2, which means that for every 2 ammoniums, I have 1 carbonate. So when I write the formula, again, ammonium being a polyatomic ion, and to show that I have 2 of them, I put ammonium in a parentheses with the subscript 2. I only need 1 carbonate, so I have CO3, and I'm done. If there is only 1 polyatomic, you do not need to put a parentheses around it. Let's practice a couple more. Magnesium chromate. Magnesium is over here, so we have Mg with a charge of +2. Chromate is CrO4, and it also has a charge of -2. So in this case, our charges balance already. +2 balances with -2 to give us our neutral 0 charge compound. So for each 1 magnesium, I need 1 chromate anion. To aluminum sulfate. So aluminum has a charge of +3. It's over here. Sulfate is SO4 with a -2 charge. I have a +3 charge on the aluminum side and a -2 charge on the sulfate side. To make that balance for my compound to be neutral, I need to multiply the aluminums by 2 to get a total of +6 on the cation side. And I need to multiply by sulfate by 3 in order to get a -6 on the sulfate side. Now +6 cancels out -6. For my final compound, I have for every 2 aluminums, I need 3 sulfates. And because I need 3, I'm going to put it in a parentheses with the subscript 3. Let's name ionic compounds with polyatomic ions. This is very simple. We write the cation name followed by the anion name. We do not change a polyatomic ion's name or formula ever. We might have Ca3PO4 parentheses 2. Ca is calcium, so I just write calcium. PO4 is phosphate, so I just write phosphate. Again, like before, it doesn't matter that there was 3 calciums and 2 phosphates. I just write calcium phosphate, and this is my final name. Let's practice a couple more. LiCN. Li is lithium. Cn is cyanide. Now notice the "ide" ending here. There are a couple of polyatomic ions that have the "ide" ending, and these are cyanide, and the other one is peroxide, which is your O2 with a -2 charge. Other than that, the "ide" endings belong to your monoatomic ions. Sr3, PO3 parentheses 2, Sr is strontium. PO3 is phosphite. And I'm done. The NH4 is ammonium. And ClO3 is chlorate. This concludes our video for today. Please come to class prepared with your notes.